Hey guys, today we'll be looking at the second part of problem 2.3 from the book Mechanics of Materials 6th edition by James M. Gear. Here the question states that a long rectangular copper bar under a tensile load P hangs from a pin that is supported by two steel posts, as you can see in the figure given here. The copper bar has a length of 2 meter, a cross-sectional area of 4800 mm square, and a modulus of elasticity EC, which is given as 120 gigapascal. Each steel post has a height of 0.5 meter, a cross-sectional area of 4500 mm square, and a modulus of elasticity ES, which is given as 200 gigapascal. Here the question in the first part has asked us to determine the downward displacement delta of the lower end of the copper bar due to a load P, which is given as 180 kilonewton. So let's look into the A part first. Here we can see all the given values and also the diagram. Now here, to figure out the downward displacement delta, where we know that the load is given as 180 kilonewton, we know that to find out the downward displacement delta of C copper, we know that delta C will be equal to P and the length of C, EC, and the cross-sectional area of the copper section. And then by substituting all the values, we get the value of delta C as 0.625 millimeter. Similarly, we can get the downward displacement of steel section, delta S, where the formula of delta S is P by 2 and length of the steel ES and the cross-sectional area of steel section. And again, similarly, by substituting all the values, we get the value of delta S as 0.050 millimeter. Finally, to find out the total downward displacement delta, we add the delta of the copper section and the delta of the steel section, and finally we get the downward displacement delta as 0.675 millimeter. In this question, again in the B part, we have been asked what is the maximum permissible load P max if the displacement delta is limited to 1 millimeter. So here we know that delta max is 1 mm. Here we know that P max is equal to delta max, and when we divide P max and delta max with P and delta respectively on both sides, we get an equation P max, which is equal to P and in brackets delta max by delta. Here we know that the load P is 180 kilonewton, and similarly from the question B, we know that delta max is 1 mm, and here delta we have figured out as 0.675 mm, and finally after calculation we find out P max to be 267 kilonewton. That's all for today. Thank you very much.